and welcome. In this video, we're going to be looking at the binomial expansion formula. And this formula might seem tedious a little bit, but it's actually very simple. So without wasting much time, let's just get right into it. If we have a binomial x plus y to the power of n, when we expand this binomial, we're going to have a summation. And this summation will start from 0. So let's say our starting point is r. We're denoting our starting point as r. So it starts from 0 and ends at the number of terms, which is n. We have r equals to 0 to n. So this is going to be the summation of n combination r. Then take the first variable, which is x. So that will be x to the power of n minus r. Second variable, which is y, and that will be y to the power of r. So let me go over it one more time. In order for us to expand x plus y to the power of n, we're going to have the summation starting from 0 to the number of terms, which is n, of n combination r, then the first variable, which is x, to the power of n minus r, then the second variable, y, to the power of r. Now let's take a look at a very simple example. If we have x plus y raised to the power of 5, our starting point is 0 and n is 5. Number of terms is 5. It's like you want to expand x plus y, x plus y, x plus y, x plus y. 1, 2, 3, 4, x plus y. So in order to do this easily and very fast, we apply this formula. Now, simply going to follow this pattern. So as I said, we're starting from 0 and we're ending at the number of terms, which is 5. So n combination r will be 5 combination 0. The first variable x to the power of n minus r, which will be 5 minus 0. Then the second variable y to the power of r, which is 0. Plus, and that is where our summation sign comes in. Okay, we started from 0, now we're going to go on to 1. So when r is 1, we're going to have 5 combination 1. The first variable x to the power of 5 minus 1. The second variable y to the power of 1. Plus 5 combination 2. First variable x to the power of 5 minus 2. Second variable y to the power of 2. Plus 5 combination 3. First variable x to the power of 5 minus 3. Second variable y to the power 3. Plus 5 combination 4. The first variable x to the power of 5 minus 4. Second variable y to the power of 4. Plus 5 combination 5. And this is where we stop because we're going from 0 to n. Our number of terms is 5. So we stop at 5 combination 5. The first variable x to the power of 5 minus 5. The second variable y to the power of 5. Alright, so recall that combination, whenever we have n combination r, it simply means n factorial over n minus r factorial r factorial. So moving on at this point, 5 combination 0 is simply going to be 5 factorial over 5 minus 0 factorial, which is 5 factorial, then 0 factorial. So that will be 5 factorial, that will be 1. 5 factorial will cancel out 5 factorial. 0 factorial is 1. So whenever you have a number combination 0, it is always going to be 1. So here we're going to have 1 multiplied by x to the power of 5 minus 0. That will be x to the power of 5. And anything raised to the power of 0 is 1. Y to the power of 0 is 1. So here we have 1 multiplied by x to the power of 5 multiplied by 1 plus 5 combination 1 is going to be 5 factorial over 5 minus 1 factorial 1 factorial. So that will be 5 factorial over 4 factorial 1 factorial. And that will simply be equal to 5 multiplied by 4 factorial. Recall that 5 factorial will be 5 times 4 times 3 times 2 times 1. But since we have 4 factorial in the denominator, we're just going to have 5 multiplied by 4 factorial over 4 factorial multiplied by 1 factorial. So 4 factorial cancels out 2 factorial, we're left with 5. So 5 combination 1 is 5. From this, we can also conclude that any number combination 1 is that number. So if we have 6 combination 1, it is 6. And any number combination 0 is 1. Alright, so here we have 5 multiplied by x to the power of 5 minus 1. That will be 5x to the power of 4 multiplied by y raised to the power 1 is y. So without wasting much time, I'm just going to use my calculator to calculate the combinations. So when I type in 5 combination 2 in my calculator, I'm going to have 10. So this is going to be plus 10 x to the power of 5 minus 2 is 3 y to the power of 2 plus 5 combination 3. Typing that in my calculator, I have 10 also. Then x to the power of 5 minus 3, 2 y raised to the power of 3, as I have here. And then I have plus 5 combination 4. And I type that in my calculator, I have 5 multiplied by x to the power of 5 minus 4 is 1. Then y to the power of 4 plus 5 combination 5 will be typing that in. That will be 1. Any number combination itself is 1. Alright, so we have 1 multiplied by x. 5 minus 5 is 0. X raised to the power 0, then y raised to the power 5. So finally, I'm going to have 1 times x to the power of 5 times 1 is x to the power of 5 plus 5x to the power of 4y plus 10x cubed y squared plus 10x squared y cubed plus 5x y4 plus x to the power of 0 is 1. So we have 1 times 1 times y to the power of 5 plus y to the power of 5. And that is how we expand, and this is our final answer. This is how we expand using the binomial expansion formula. I've also explained how to use the Pascal's triangle. Click on the video you are seeing on your screen right now to check that out. Thank you for watching.